Hello everyone. This is a quick guide on how to set up the Festo Motion Terminal in Studio 5000 from Rockwell Automation. For this video, I'm going to be using a couple of documents, mainly this one right here on the screen, the Quick Reference PLC Programming, and I'm also going to be using this other document, which is the description of the add-on instructions, AOIs, or function blocks in the Studio 5000 environment. So let me close these two things up. I have already Studio 5000 open, but first of all, I'm going to start by showing you what I have in terms of configuration. So for that, I'm going to open the Festo the CPX Festo maintenance tool, which is going to allow me to scan the valve terminal that I have connected right now. So for that, I'm going to click here, establish online connection to the valve terminal, and then I'm going to specify the IP address here. Usually this should be a happy face, but right now I'm using a virtual machine and it's not very straightforward in my topology right now, but I think if I click next, it should connect fine. So let's see, right now it's connecting, and it's uploading the configuration from the terminal. So right now you can see I have the first module on the terminal is an FV36, and I'm also going to show that to you on the video here. So this is the configuration that I have, an FV36 on the left-hand side, and then I have 4 valves and 2 input modules on the right-hand side. And then what I have for controlling or to control is what I have to control is this actuator right here. So now that you know what I'm going to be controlling, there's a couple of things here. As you can see, this is already communicating something, so I can see some information coming through the inputs and nothing going through the outputs because I haven't commanded anything. A couple of things that are important. This software tells you what's the size of I/O for this particular configuration. So you can see down here, I have 50 bytes of inputs and 48 bytes of outputs. What else is important here? I think that's, I mean, just for today's example, that's it. One thing that we're going to do today here is we're going to click File and then Export and then RS Logics, and this is going to create an L5K file. This is a really great feature because then when I do this, this is going to create. I already did it, but this is going to create exactly this file, which includes the size of the terminal and the modules that are there. Also, it includes some parameters. I canceled this because I already created it. But also it includes some parameters. So if you double click on any of the modules that you have here, you can specify some parameters here. So if I was to change any of these parameters after I hit apply and all that, I click OK and so on. When I export, all of these parameters are going to be saved like I established them here. So that's how you can use this little piece of software. So since I already did the export, I'm going to go to, I have 2 instances open of Logix. This is the one, so I'm going to show you, file open. This is the one that I created. I exported from this software, right? So I already opened it, and it's this one. And as you can see, it automatically generates this Ethernet module right down here. It specifies the size, right? I told you 50 and 48 bytes. So if we go back here, you can see 50 on inputs. Let me put it to the side. 50 on inputs right here, and 48 on outputs right here. And then the configuration, this includes all of the parameters that I mentioned. I mean, I showed you a couple, but there could be many other parameters. Like you can see here, the Ethernet IP module has its own parameters, but we're not going to touch on that today. Anyways, this is great because everything is configured for me. And then the other thing is if I go to the controller tags, also here's my module, and there's also some description for each of the tags here. So you can see these first 2 bytes are diagnostics because of the way that I have my module configured on the deal switches. Here it's already saying here you can see the second group on the deal switches on the module. I have one of the switches on, so it's sending me some diagnostics, in this case 2 bytes, and then the remaining of the bytes are for the valves, right? For this portion over here. So how many bytes per valve? And I'm going to show you that here. So if we open this document and we scroll down, actually it should be right here. It tells you that each valve occupies 6 bytes of inputs and 6 bytes of outputs. And there's a description of what each byte and even what each bit does. But we're not going to get into those details today because we're going to use the add-on instruction. Okay, so I have that. Then the next thing that you're going to do is you're going to open your own project. In this case, mine is this one. And it is as easy as just put your two projects side by side. Remember, this could be the project from your machine, right? And then what you're going to do is simply drag and drop, right? So drag the one from the L5K export that we did and drop it on your project. I already did that here, so that's why I have it already on my project. You can also right-click on the one that you're bringing in, copy, and then paste under Ethernet, and that's it, right? So that's how you do the export and import process. Okay, so now we're here. I already have my Ethernet module with the right configuration. Even the IP address is correct. So the next step is going to bring in those add-on instructions. And how do you do that? Well, you can download the add-on instructions from the Festo website, and I'm going to show that to you here. So I go to the Festo website, and I type in VTEM, and then support and downloads. And then I navigate to the software tab, and then you're going to see here function blocks Rockwell. Open that up and download this file. This is a zip file. You can see it down here, right? Okay, I already, as you can imagine, I already downloaded those files, and I'm going to show you what's in these files. So here, this is what you get, and what you get is the documentation, of course, in English and German. We're going to use the English one, which is this one, okay? And you also get the add-on instructions themselves. So you get a folder with all of them, which is this file. If you import that, it will bring everything in it, and you get them separately. Usually, for simple tasks, you're just going to use this one under operation valve control, and that's actually the one that I brought already in here. So how do you do that in case that you've never used add-on instructions? You right-click on here, import add-on instruction, and then go navigate where that was, right? In my case, it was under operation. Bring that one in, and as soon as I do that, it brings these three files, or these three AOIs, okay? So the next thing that we're going to do is we're going to, let's say my main routine right now, it's empty. So I'm going to create a new rung, and then I'm going to just drag and drop. Or if you don't want to do that, you don't want to do it that way, you can always click in here and add on, and then you have it here. We're going to use this one, valve control. I usually do it this way. So valve control, drag and drop, put it in there. That's it. So the first thing that we got to do is we got to create an instance for this AOI. And in my case, I'm going to call it valve control 3. I already declared this. So how does this look like? I'm just for the sake of the exercise, I'm going to create it in a different way. Valve control, let's say valve control number 2. For valve number 2, okay? So you can right click on it and then new valve control 2, or usually I just do control W, which is the same thing. So new valve control, and you can see this is a data type valve control. So let's create that. Okay, now it's going to ask you, okay, now give me my inputs and outputs, right? So remember that I told you that each valve takes 6 bytes, right? So let's see here. If we navigate to the inputs, you see here we have the diagnostics, the first 2 bytes for the general terminal, but then here starts the first byte for the VTEM. And you can see we have a bunch of bytes because it always maps 8 valves independently of if you have 1, 2, 3, 4 valves. In my case, I have 4 valves. But if you have 4 valves, it's always going to map for 8 valves. So that's why you get 6 times 8 bytes. Okay. Okay, we go back here. So this is going to be my first valve. So from here, 1, 2, 3, 4, 5, 6. This is my first valve, and then this is my second valve. So data 8, input data 8. Okay, let's go back here, and here's a thing though. If you look at the data type of this variable, this is an array of integers, right? So let's see that. Valve control, I'm going to open the AOI and then open the local tags of that particular AOI, and then you'll see that this is expecting a data type of an array of integer 3, right? So 3 integers. If I go back here, I cannot link directly the 3 integers. So what I'm going to do is I'm going to add 2 more rungs and put this one in the middle. And I'm going to use a copy instruction in each of those. And what I'm going to do is just bring the raw data from the inputs directly to a variable of type int, of type array int of 3. So I'm going to show you that. Source, it's coming from where? We said inputs, and then here inputs. Okay, so we said this is not the one, this is the first valve, right? So in the first valve occupies 6 bytes. So 1, 2, 3, 4, 5, 6. So then it's this one. This is the second valve, the first byte of the second valve. So we double click on that one, that's going to be the source. Then the length, remember it's 6 bytes, okay? And the destination, this one I'm going to call it, let me see, I'm going to call it array of integers, and I'm going to call it valve control 2, because this is for valve 2, and then inputs, okay? And then, of course, I need to declare this because, as you can see, this is not yet declared. Undefined tag, so new. And then here, I'm going to specify that I want this to be a type int of 3, an array of 3 integers. Okay, create. And I have to specify, this is on the compiler of the software, I have to specify which is going to be the first position of what I'm sending. So that as soon as I add that, the error went away. So I'm going to delete it so you can see the difference, right? So if I don't specify where it's going to begin to copy the information, it's still giving me an error right here. So I have to specify 0, and that's it. And then I'm going to do the same thing for the outputs. So what I'm going to do now is I have to specify, now this is going to be the opposite though. I'm not reading from the controller tags, right? From here, I'm writing to the controller tags. So that's why we added that at the end. Oh, sorry, at the end of the rungs. So the source is going to be a new variable that I'm going to be calling AI valve control 2 outputs. And then, excuse me, I'm going to declare this new, and then type int on size 3, create, and then length is going to be 6 bytes. Again, remember each valve has 6 bytes, and then the destination is going to be what? It's going to be my outputs on the CPX data, and then here we don't have any diagnostics, so this is important too. On the outputs, you see here I have 2 bytes for diagnostics from general diagnostics out of the terminal. On the outputs, I don't have that. I have just the outputs, right? So I don't have those first 2 bytes of diagnostics. So that means that if I go here, and remember that I'm working with the second valve. So if I go here and I look for that output data, so this is my first valve, and each valve occupies 6 bytes. So 1, 2, 3, 4, 5, 6. This is the next. So this is valve number 2. And remember, it's still giving me an error because I have to specify the first data point, right? And that's it, the error went away. What else am I missing here? So now I can use these variables to point them to here. So now I can say, okay, the data coming from the motion terminal, I want you to put it in here. And the data going to the motion terminal, I want you to put it in here. So now let me see. I want you to so now once we have that, now we have to point where this information coming from and where the information is going to. So what we're going to do is, remember that we created these variables here for inputs and here for outputs. So we're just going to point these variables here. AI valve control inputs and AI valve control to, then this is going to be outputs. And that's it, right? So now all of the errors went away. So I can now run this program. So I also have another one which I already created, which is this one, test. And this here I have the same thing but for valve 3. So that's why you're going to see a difference in the addressing here. So 8 and 6, and here I just have 14 and 12 because this is the third valve instead of the second one. Okay, what I'm going to do because the third valve is the one that I have plumbed to my system, I'm just gonna add another run here, and I'm just gonna call that routine that I call test, just so I can run the valve that I need. So now it's going to jump into here, and this is the one that I'm going to be controlling. All right, so let me download this one, this program that we just created. Download. While that is downloading, what I'm going to do is I'm going to open a web browser and I'm going to type in the address of my VTEM. Now, remember that this address that I typed in is this one, right? Not this one where I'm connected to the Rockwell PLC. It is this one. This is the one that we use for this web server. And then the next thing that I'm going to do is I'm going to go into configuration so we can see what's going on. Accept that. And right now it's saying that communication is interrupted. Let's see why. I go back here and let's change it to remote run. Okay, it's running. Everything is okay. My Ethernet module is running, which is perfect. Okay, so now let's go back to here and see what can we do here. So let me put it side by side. Hopefully you can see there. Okay, now we can see. So I'm on my test here. What I'm going to do is I'm going to enable this block. And now, as soon as I enable this block for valve number 3, you notice that error went away. Okay. Now, the next thing that I'm going to do is remember I'm going to be working with this third valve. Okay. What I'm going to do now is I'm going to open this other document and show you a couple of things. For today's example, I'm going to be using motion up number 8. Okay, so I'm going to scroll down to motion up number 8. Here, the first thing shown here is some parameters that you can change here. So I'm going to actually let me remove the control from this guy. Go back here and going to maximize this so I can show you. The motion up number 8 is this one, and you can count them from here. 1, 2, 3, 4, 5, 6, 7, 8 is this one. I selected. Now I can log in. You can check the password on the user manual. And then I'm going to take the right permissions from the PLC. Right now you see that there's an error. I'm not going to acknowledge it because I want to acknowledge it from the PLC just to show you how to do that. But what I wanted to show you is this. Most of the motion apps, they have their own configuration or their own parameters. In this case, this one expects the user to specify what kind of actuator you're using, the stroke, the installation angle, tubing length and so on, right? So you have to fill this up. Then the other thing is the load. So once you're done with that, you click here and accept values for configuration and then save configuration. You have up to 5 different parameter sets. You can change those. Okay, so I just wanted to show you that. I'm just going to remove that then, and we can just again place it side by side. Let's go to here so you can see what's going on. Okay, so now I'm going to enable it again. Now there's nothing running right now. What I'm going to do is I'm going to be changing these variables. Now, what does each variable mean? If we scroll down to on this document, we go all the way to valve control here, page 19. You see a description of what each parameter means, right? And so the set valve mode here, this I'm going to set it to number 8 because that's the motion app that I want to run. Okay. The other thing that you can do is you can always go here and you can say, okay, this is the number 8. And so let's see what happens. I set that to number 8. Where's my Google Chrome? So set this to number 8 and nothing happens. But it's telling me something here. It's giving me a value 1037. So let's see what that is. I know what that is, but I want to show you where to find it. So if we go back to this manual for the AOI and we search for 1037, you'll see that it's saying acknowledge needed, because right now what happened is that my motion terminal, I just powered it on. So it's saying, okay, I'm just starting. I need I need you to acknowledge that there's an error, right? Remember that there was an error here. I can acknowledge it from here. So you have this manual acknowledge. I'll make it true. And then you'll see that now it's changing to the motion app number 8. This icon is saying that it's running a valve self calibration because this is the first time that I run it. So after that is done, it's going to show an R, which is running. So once I acknowledge the error, I can just clear this. And I can do the same thing with valve number 2 because we already have it mapped, right? So I can go back here and I can enable this and send it an acknowledge. So now you see valve number 2 changed to configurable. It changed to configurable and not to run because I didn't specify anything on the valve mode, right? You see here, value 0, so there's nothing. But the valve says, okay, I'm ready to run if you need me to. Perfect. So let's go back to valve number 3. So what I'm going to do next is I want that actuator that you see there on the screen, I want that actuator to move forward and move back. Why is this motion app special is because what's nice about it is that it allows me to control, you can see here, it allows me to control flow and pressure with the same motion app, okay? And so you see here, let me put this to the side so you can see. Okay, we have control. We have app control right here, and it says that in this app it is not used. Okay, so that's good. App control, sorry, app option, that was app option, this one. App control, which is the next one, it says that depending on which number we set, the valve is going to do a different thing. So if we set it to 0, then it goes to blocked or close centered. If I set it to 1, then the actuator is going to advance. If I set it to 2, it's going to retract, and then 3, it's going to exhaust or going to exhaust centered, right? And then what else is next? Value, set point value 1 and set point value 2. So you can see here, set point value 1, it says that 10,000 means that it's 100% open, and this is metering out. So this is like regulating your flow controls. Instead of having flow controls, you notice here that I don't have flow controls. I only have standard quick fittings, right? So I can regulate the flow here, and I can also regulate the pressure. So on set point, sorry, that was value 1, this one with flow, and set point value 2, which is this one, I can regulate pressure. So from 0 to 8,000 millibars. Okay, let's give it a try. So I'm going to set it to, let's say, 5,000 millibars, which is 5 bars, and I wanted to go slowly. So I'm going to set it to 500, which would be 5%, right? Okay, so I wanted to advance, and then I would need a number 1 here on the app control. Okay, app control, advance, and it starts advancing slowly. Okay, perfect. Let's make it retract. For that, I will need a number 2. 2. It retracts slowly. Advance again, retract, perfect. Now, if I wanted to make it faster, I can change this to, let's say, 50%, which would be 5,000, right? Advance, retract, exhaust, and now I should be able to move it manually. Perfect. So if I set it there, and now if I set it to 0, then it would be close-centered, right? It will hold its position because it's close-centered, and I can't push it or pull it. If I send it again to 3, or I set app control to 3, then it's exhausted again. So now I can move it freely. Okay, I'm going to retract it, and I'll set this app control to retract. Now it's retracted. Now let's do advance. Perfect. And let's change this pressure. Well, let me retract it, and I'm going to change the pressure. I'll leave it at 5,000, but I'll go slowly, 500 again. And what I'm going to do is I'm going to advance it. So I'll try to stop it with my hand. Here, I can't stop it because it's going at 5 bars, right? But if I retract it and I set it to, I don't know, let's say 800 millibars, which is 0.8 bars, right? See if I'm strong enough to stop it. So now it's trying to go, and I can stop it, but as soon as it starts pressuring up, it's going to push back. Okay, let's set it to, I don't know, 350 millibars, and let's see if I can stop that one. One, and I can stop it now. I can even push it back, right? Because the pressure is so low. Perfect. So it's working fine. So now, as you can imagine, you can now change the behavior of a pneumatic actuator on the fly, because what if you set these values, or you link these values to a certain controller or a certain graph where it can be, I don't know, a sinusoidal, it can track a sinusoidal path or something like that. Now you have full control over a pneumatic actuator. And then on the right-hand side, you have the feedback. Sorry, that's my compressor. Let me switch it off. On the right-hand side, you have the feedback right here, which is this, right? So it tells you if it's retracted or advanced, depending, because I have position sensors mounted in here. And the actual value, so it'll give you the pressure on both ports. So port 2 and port 4, it'll give you the actual pressure in that particular port. So that's how it works, and that was just one of the different motion apps that we have available on this Festo motion terminal. Let me scroll down so you can see the other ones. Just a glance, I guess. You can change the valve functions. You can proportionally control a directional valve, proportional pressure regulation, model-based proportional pressure regulation, supply and exhaust airflow control, and so on. So you can see we have different ones. Right now, I just show you the one. I just wanted you to get an idea of how this works on the Rockwell environment. And as you can see, it's pretty easy to set up if you follow that path of exporting the I/O from here. So hopefully you'll find this useful, and you're going to be able to use this later on. Thank you for watching.